Okay, here's our second foldable. So remember there are 5 congruence postulates, theorems altogether that we can use for triangles, so that way we don't have to prove all 6 of the sides. So the last foldable went over the side, and the one where you have a side and then an angle and then the other side that's both attached to the angle in the middle. So we have 3 more of them on this second foldable. So this video does all 3 of these. And remember the outside, we're going to add some notes in class, but we're going to just do the inside of it right now in the video. So make sure you have some colored pencils. Okay, so the first one we're going to do is the AAS, congruence postulates, the AAS. Now what you want to note this is the order of how these happen out here. So if you take a look at this here, it says you have an angle, and then you have another angle, and then you have this side. Note this side is only touching one of the angles. Side only, touching one angle. Look right here. You see how this S is right here? You see it's only touching this one A. It's not touching the first A over here. So keep that in mind when we look at one of the triangles when we're all done, because it has to have an A and another angle, but it has to have the side only touching one of those angles, not both of those angles. Okay, so that's why the order of this does matter. Okay, so now we can name them in a clockwise or counterclockwise direction. It doesn't really matter when we name them, but it has to be true that the side that you have can only be touching one of the angles that you have, not both of them. Okay, so it says if you have 2 angles and the non-included side. So non-included means it is not in between. So you might want to put a little note. Non-included means not between. So that means that the side that you have cannot be between the 2 angles that you have. Okay, so if we have 2 angles in the non-included side, are congruent, and one triangle is congruent to the same thing on the other triangle. Okay, so this is what it looks like in a picture. Sometimes it's better to look in a picture. So let's just look at this pink guy right here. So if you look at this pink guy, notice how the side I have is over here. Do you see how this side does touch this little purple angle in the corner? But do you see how this side does not touch this angle? So this is a classic case of we have an angle, and then we have another angle, and then we have the side. And it could be, like I said, in any order. It could have been an angle and a side over here. It just has to be true that the side that we have is only touching one of these A's, not both of these A's. Okay? So let's go ahead and try this proof. So we want to prove that triangle RST, so I'm going to do RST, I'm going to do it in yellow, is congruent to UVT. U to V to T. So that's this green guy over here. Okay, we want to prove that these 2 triangles are congruent to each other. Okay, so let's start with our statements. And our reasons. Sorry, I'm writing on my computer screen, and so it's never beautiful, which is why you should have the volume up. Statements and reasons, statements and reasons. The first statement we have here. The first statement I want to talk about, they have marked this little tick mark and this little tick mark. So that means the segment from R to T is congruent to the segment that goes from T to U. So I'm going to talk about this segment is congruent to this segment. So we've got R to T, and remember the little segment bar on top is congruent to T to U. And that is given because they put tick marks on it in the picture. The next thing we have markings for, it looks like this angle is congruent to this angle. They have put markings. So number 2, let's name this angle. Can I name this just angle S? I actually can, because there's only one angle at this location, vertex X. So I'm okay to call it just angle S. If you want to call it 3 letters like R, S, T, that's okay. Or T, S, R, that's okay also. But I'm going to go short and sweet. Is congruent to this angle V over here. There's only one angle coming out of that vertex, so I can just simply call him by one letter. And that is a given because it is marked in the picture. Okay, now that is all that is marked. But if I look at this picture, I have that classic X in the middle. Remember when you have an X and you have angles on opposite side of it, they're going to be congruent to each other. So that means this angle here is going to be congruent to this angle over here. What kind of angles are those? Those are vertical angles because they're across from each other on X. Now, I can't call this guy just angle T because there's a lot of angles going on here at T. So I'm going to have to call him by 3 letters with the T in the middle. So I can say R to T to S. So I could call him angle R to T to S is congruent to, I got to get this angle on this side. So same thing, I got to do a V shape with the angle in the middle of it. So I could do V to T to U. So angle V, oopsie, that's not a V. Angle V to T to U. Those are congruent to each other, and that is because vertical angles are congruent, or vertical angle postulate. Or is that a theorem? I don't even know. I always say vertical angles are congruent. I better check that in my thing. I think that might be actually a, let's see, vertical angles. Remember in the back of your book you have the things. Vertical angle postulate. Nope, it is a postulate. Okay, I was good. All right, so now my question is, remember what I said, look at only one of the triangles. Because I have 3 parts now, so I might have enough stuff, right? So I'm going to look at only one of the triangles. I'm going to look at the yellow guy. So I'm going to scribble out the green guy in my head. Don't you scribble it out. I'm just thinking of him. So only look at one triangle. So look at one. Okay, so when I look at this triangle here, think about the pieces that we have here. So it looks like this is clearly a side because it's segments. This is clearly an angle because it has angles. And this is clearly an angle because it has angles. Duh, look right here, angles, angles, and segments, right? So it has a segment and 2 angles. Now, the question is, do we have it set up so that we have the side, the S that we have, is it only touching one of these A's? So I can look at my picture here. That's why I like to mark it up. If you go through a whole proof and you do not mark up your picture, there's some problems. Okay, so my question is, I have this side, and then I have this angle, and then I have this blue angle. So my question is the side that I have touching both of these angles? And it is not. You see this red line? It is only touching the purple angle. It is not touching the blue one. So we actually do have angle, angle, side. And if you think about going around this picture, I could start right here and do angle, and then side. You see how the side I have is not the one in between it, because if it was in between, it'd be touching both, and then we wouldn't have angle, angle, side. So I can prove that these triangles are congruent. So prove what we want. That is triangle R to S to T is congruent to triangle U to V to T. And my reason is angle, angle, side, congruence postulate. Okay, make sure you have all good notes for yourself. Next picture is, you might be like, hey, this is the same thing. It has 2 A's and an S, but there's a little bit difference because for this one, look where the S is. Do you see how the S is right in between these? So that means that it has to be the side in between, touching both A's. See how this S right here is touching this A and this A? So that means you have the 2 angles and the side is the one in between. So it's going to be the side or the one in between. It's going to be included or in between. All right. So you see a classic picture of it right down here. You see how we have these two angles? And we have the side that's in between them. So basically the side touches this angle and this angle. Has to touch both of them. And then you have angle, side, angle. All right, let's try to do this proof here. So we have two different triangles. We have this green guy on top and this pink guy on the bottom. That was bad coloring on my part. All right, so let's go ahead and see what we have here. So let's start with our statements and our reasons. Okay, statement number one. Let's look at this picture. So we do have this, look at this blue angle down here and this blue angle up here. Those are definitely marked congruent. So let's go ahead and do those first. So we have angle. Now I can't call this angle R down here because I have this little angle R, this little angle R, I have the whole big angle R, so that's not gonna work out. So I do have to use 3 letters. So I'm gonna call him P to R to Q. Remember, just trace with your finger, P to R to Q. Did it make that angle? Sure did. So I named it right, P to R, P, R, Q is congruent to, I need this angle over here, so I'm going to call him S to Q to R. Angle S, Q, R. So that is going to be given. Okay, now you see these little arrows. What do these little arrows mean on the side? It means that they're parallel. So parallel lines are lines that never ever cross. But these could be parallel, right? This does not mean that these two are congruent. Clearly, this one down here is longer than that one. So parallel and congruent do not mean the same thing. So we cannot put that in our, we can say they're parallel to each other. Like I can go ahead and make a statement like, oh, I can say that segment PQ is parallel to segment RS, but they're not congruent. So we can't use that as a congruent statement. So it's not going to work with a congruent statement over here, but I can still state it. It is a given if I want to state it because I might be able to use it for something else. Okay. And I actually can. Now, if you go back to parallel lines cut by transversal, so I would like you to take a light color so that you can draw over top of this. Do you see these parallel lines? So get a light color. These parallel lines are definitely cut by this transversal. Do you see this diagonal transversal? Now remember when we have parallel lines cut by transversal, you have a lot of congruent angles. So if you look in this picture, we have to review those because we do have alternate interior angles. You see how this forms like that classic Z? So that means that this angle right up here is congruent to this angle down here. So we do have some congruent angles because of alternate interior angles are congruent. Okay, I need to get rid of some of that because I can't see my letters underneath it. Okay, so I'm going to go ahead and say that this angle is congruent to that angle. So that would be a P to Q to R. Angle P, Q, R is congruent to angle down here. That's going to be an SRQ. Those two are congruent to each other because alternate interior angles are congruent when we have parallel lines, and we do have parallel lines. Remember, if you didn't have parallel lines, you couldn't use that. Okay, we need one more thing because so far it looks like we have an angle, right? That's an A. This number 2 does not count because it's not a congruent statement. This counts because it's an angle, right? 2 angles congruent. So far we only have 2 A's. So we need an S in between those 2 A's. Now here's the deal. We can use what we used on the very first theorem. If you look at this line in between here, do you see this side right here? That side, R to Q, is shared by both of these triangles. RQ is a side of this green triangle, and RQ is also a side of this pink triangle. So we can use that one as R to Q is congruent to R to Q. Now, if we have the exact same thing equal to the exact same thing, what property was that called? That is the reflexive property. Reflexive property. And I'm going to put an X on him so I know that I proved him congruent. So we have now found another S. So we have three pieces now. We have two A's and an S. Now we have to go over here and we have to see, is the S in between the two A's, touching both of those A's? So I'm going to look at the pink triangle, okay? So I'm going to pretend like I'm going to scribble out this triangle on the top here. Pretend like I'm not looking at that. Now, let's see what I have marked on this pink triangle. I have this angle here, this black one, and then I have the side, the green one, and then I have this blue one that I could barely see underneath here anymore. So I have the black one, the blue one, and this side. So my question is this side touching this black angle? Yes. Is this side touching this blue angle? Yes. So therefore, I do have the side that's touching both of my angles that are marked. Now, once again, I don't care about this angle out here because he's not even in my list of stuff over here, right? So I can prove these two triangles congruent now. I can say that triangle PQR is congruent to triangle RSQ. And my reason is because I have angle, side, angle, congruence postulate. Good? Okay, last one. Okay, this is HL. So this is hypotenuse and leg. Now, if you have a right triangle, if this is my right angle down here, the side opposite is always called the hypotenuse. As quick review, this is my hypotenuse, and if you can't spell it, it's right there. These two are both legs. So this is a leg, and this is a leg. So the two legs attach at the right angle, and the hypotenuse is the side across from it, which will always also be the longest side in a right triangle. If you had forgotten that, they should have talked about that in middle school. Okay, let's see if we can go ahead and do a proof for this. So this is what this says. This says that, erase this weird line here. This says that if you have the hypotenuse, like this side opposite the right angle, and a leg of a right triangle congruent to the hypotenuse and leg of another one, then automatically those two are congruent. So you need a hypotenuse and a leg. So here's the important stuff though. You need to have the hypotenuse and the leg, but it must be a right triangle. If you don't have a right angle, then you cannot use this theorem. Okie dokie, you need a right triangle. So it has to have a right angle. Okay, so let's go ahead and look at this. Let's see if we can. Let's put some statements and some reasons. Okay, let's state the obvious here. So we do have some markings. I'm going to do this red side is congruent to this red side. So that is from A to B is congruent to from A to C, and that is given because it's marked in our picture. Okay, we do have something else marked in our picture. We have this little box, right? What does the little box mean? The little box means that we do have right angles, right? So number 2, let's name these two angles down here. Now we can't say angle D because there's a lot of stuff going on there. So in order to name this side, I'm gonna have to call him B, D, A. So angle B, D, A is congruent to, I gotta name this side over here. So that's C to D to A, angle C to D to A. Those two are, let's not say congruent. Let's put it, this guy and this guy are. We do know they are congruent also because we have another theorem that says all right angles are congruent. But for this theorem, we just have to say that they're right. So these are right angles. And the reason they are right angles is because it is given in our picture, right? So we don't, it is true that they are congruent, but we don't have to say they are. We just have to say they're right angles because it says hypotenuse and leg of one with the right triangle. So he is a right triangle. So we have leg. Now we don't have anything else in our picture, right? I'm going to erase some of the stuff in our picture because it's a little bit busy in the middle here. But we do have that infamous shared side in the middle. So from A to D, isn't that a side of my yellow triangle over here? And it's also a side of my blue triangle over there. So we can use reflexive property. We can say that side AB, oh, that's a D down at the bottom, AD is congruent to side AD. And the reason for that is reflexive property. You might wonder, why do we have to say that? Because we actually have to have the statements over here. So in order to use this theorem, we have to have a hypotenuse and a leg and a right angle, right? Hypotenuse and leg and a right angle. So do we have we stated it here? Do we have a hypotenuse and a leg and a right angle? Okay, so let's double check and look. Now remember, look at only one of your triangles. So I'm going to scribble out this side here. And I'm only going to look at the yellow guy. So when I look at this little yellow guy, I do have a right angle and I have stated it, right? So I've got my right angle. Right here is my right angle, right? Check. Do I have a hypotenuse or a leg? So remember, go across from your right angle. This right here is my hypotenuse, right? So I do have my hypotenuses. So this is my H right here, right? Because that is side A to B. And then do I have another leg or not? So if you look, this side right here, this green side going up and down, that is going to be my leg. So I do have my hypotenuse and my leg and my right angle. So that means that I can prove these two triangles congruent to each other. So I can say that triangle A, sorry about the A, B, oh my goodness gracious, I better start over. Triangle A, B, D is congruent to triangle A, C, D. And my reason is hypotenuse, leg. I like to put the hypotenuse, leg, right angle. I like to use a little right angle box. Hypotenuse, leg, right angle theorem. This one's a theorem instead of a postulate, but it's still something you can use in a proof. Okay, make sure you have all your good notes.